Bismillahirrahmanirrahim. Sallallahu alayhi wa alihi wa sallam. Allahumma rabbi zidni ilma. Sallallahu alayhi wa alihi wa sallam. Ameen. Alhamdulillahi rabbil alameen. In this lecture, I will discuss question number 6 of June 21, paper 1-3. So, first part of this question is, by first expressing f of x and g of x in completed the square form, express g of x in this form. So first we have to express f of x and g of x in the completed the square form. So there are two methods to express these two in completed the square form. This is the first method, f of x. Those who know completed the square form method, they can directly convert this equation into completed the square form. So x minus 1 whole square plus 4. This is the completed the square method. But those who do not know this method, they should use comparing the coefficient method instead. X square minus 2x plus 5. Wait, this should be f of x, x square minus 2x plus 5, a x plus b whole square plus c. This is the comparing the coefficient method. So students who do not know this completing the square method, they should use this method instead to convert this into this form. And same is with g function. They should use this method to convert g into this completed the square form. Now gx. So I'm converting directly gx into completed the square form. So this should be 4 minus 4 plus 13. So the completed the square form of gx is x plus 2 whole square plus 9. So we have done the first part of this question, completed the square form for both. The second part of this question, which is very important, we have to express g of x in this form. We have to understand this equation carefully. G of x is f of x plus p plus q. If you are good at transformations of function, then you can easily understand this equation. See, this means horizontal translation with vector minus p, and this means vertical translation. So this is combined translation. Combined translation with vector minus p and q. Now, to express g into this form, we have to compare these two equations. We have to compare the x component of f with the x component of g to get the value of p. And then we have to compare the y coordinate of f with the y coordinate of g to get the value of q. See, this is the way to compare these two. X minus 1, this is the horizontal component of fx. We have to add p here. So this will become x plus 2. This is object and this is image. Meaning x minus 1 plus horizontal component of translation will give you this image. So the value of p will be 3. This means when you will add 3 here, you will get x plus 2. And for y component, for q, you should compare these two components. You have to add q here. So 4 plus q will give you 9. So q is 5. Therefore, x plus 3 plus 5 is the right equation of g in terms of x. And the translation vector is minus p means minus 3 and 5. So this is the answer of part A of this question. First, convert these two into completed the square form, either by using completed the square method or by using comparing the coefficient method. Number two, understand this transformation carefully. This is combined translation with vector minus p and q. To get the value of p, add p into horizontal component of x. You have to make this x plus 2. So to make this x plus 2, you have to add p here. You have to add something here, which is p. So p is 3. Similarly, if you will add q into 4, you'll get 9. So the value of q is 5. So when you will substitute p here and q here, you'll get the equation of g in terms of x, f of x plus 3 plus 5. And this is the translation vector. So the vector is minus 3 and 5. We all know when this is plus p, then we write minus p here. This is the rule of translation vector. Now the last part of this question, describe fully the transformation which transforms the graph of fx onto gx. We already have done this in part 1, that this is translation with vector. You just need to write translation with vector minus 3 and 5. This is the description. This is all. I hope this will help you to understand the solution of this question, this lecture. Allah Hafiz.